Hey guys, today we are going to start a new unit. We're going to go over polynomials and then just kind of learn what that is. But before we can do that, we need to review some of our exponent rules. So we are on pages 1 and 2 in our new set of notes. Okay, so today we're going to focus just on multiplying and seeing if we see any patterns and coming up with any rules to simplify. Okay, so the Bab family is moving, and Mr. Bab has several cube-shaped moving boxes that measure 5 feet long on each edge. The volume of one moving box can be expressed using the exponent below. Label the parts of the exponent, write it in expanded form, and then to simplify it. Okay, so we would call this 5 raised to the power of 3. So this 5 we call the base. And this little 3 we call the exponent. So just reviewing what an exponent means, 5 to the third expanded means 5 times itself 3 times. So an exponent means the base number multiplied by itself however many times the exponent is, right? Then if we were to simplify this, we could multiply 5 times 5 and get 25. And then multiply 25 times 5 again and get 125. Okay, so now we're going to look at various ways we can write exponents and see if we can simplify using any patterns. So understanding exponents rules can help us simplify numeric and algebraic expressions. In A and B, write the expanded form of the product, then express the product as a single base raised to an exponent. So this is what we call a numeric exponent, because we have numbers and we have exponents. Okay, so we're going to see if we can simplify this. So we have 4 to the second times 4 to the power of 5. So we're just going to expand 4 to the second real quick. So 4 to the second just means 4 times 4. Okay, and then we're multiplying that by 4 to the fifth. 4 to the fifth means 4 times itself 5 times. Okay. So then I want to see if we can maybe simplify this. Well, this is just all multiplying, and everything that's being multiplied is 4. So our base is 4, okay? And it's being multiplied a total of 7 times. So we can rewrite this as 4 to the 7th. Okay. For the next one, we have n to the third times n to the third. Now this is what we call an algebraic expression because we have variables instead of numbers for this case, but we can still follow the same patterns. So for this case, n to the third would be written expanded out as n times n times n. Then we're multiplying that times n to the third again. So we're going to write n times n times n. And now if we think about how we could simplify this, again, this is just multiplying everything together. The base is an n, and it's being multiplied a total of 6 times. So we could write this as n to the 6th power. Okay. So I want you guys to take a second, write down any patterns that you may notice. Okay, so hopefully you've noticed that if we are just multiplying these together, we're not changing the base. Okay, we didn't change the base of 4 and the base of n, but all we did is we could just add these exponents together to come up with the new total. Okay, so this is a power of a product. We have powers, which means exponents. Product means to multiply. So when we multiply exponents, we can keep the bases the same. And the simplified version would just be to add the exponents together. All right, so we're going to now kind of practice this a little bit. Apply the power of product property to write each product as a single base raised to an exponent. So we have x to the 5th times x to the 12th. So if I have 5 x's multiplied together right here, and I have 12 exponents multiplied right here, that means I would have a total of x being multiplied by itself a total of 17 times. All right, n to the 4th or times n to the 4th. Okay, we have 4 n's being multiplied right here, 4 n's being multiplied right here, or 9's, excuse me. So that would be a total of 8 9's being multiplied together. Now we could actually evaluate 9 to the 8th, but that would be a really, really big number. If it's a smaller number, we will simplify those, but n to the 8th, we be in the millions. So, all right, this one we have b times b to the 7th. So we have a b right here, and we have b to the 7 right here for a total of 8. Okay, so one thing you can do is if you don't see an exponent on a variable, and we're talking about exponents, you could put an imaginary 1 and then just multiply that 1b multiplied by 7 more b's multiplied together for a total of 8. Okay. All right, now this final one, we have 3 to the 3rd times 3 to the 4th times 3 to the 5th. So we have 3 3's, we have 4 3's, and we have 5 3's. So it's multiplied together, that would be a total of 12 3's being multiplied together. All right, then we have this problem when expressing, so these just make it a little bit harder. When expressions contain different bases, we're going to group powers with the same base and then apply the power of product property. Okay, so what we're going to do is we're just going to visualize we have 3x to the 4th times 5x to the 5th. So first, I'm just going to group together my regular base numbers. We have 3 times 5. Okay. Then I'm going to group together my common bases of x to the 4th times x to the 5th. Now I can multiply regular base numbers together. 3 times 5 is 15. Again, we are multiplying, so we're multiplying regular numbers together. Okay. Then we have x to the 4th times x to the 5th. That means we have 4 x's, 5 x's being multiplied together for a total of 9 x's being multiplied together. So this simplified would be 15x to the 9th. All right, this next one we have 4x to the 3rd y. This is being multiplied, we have parentheses instead of a dot for multiplication, times 6x to the 2nd y to the 3rd. So again, I'm going to visualize, or you can group it. We can first just group or visualize the multiplication of the regular base numbers. Okay. Then I'm going to group the bases of an x. So I see x to the 3rd times x to the 2nd. Okay. And then I see the final different base of y's. So I see y times y to the 3rd. Okay, now I'm going to simplify these together. 4 times 6 being 24. X to the 3rd times x to the 2nd would be a total of 5 x's being multiplied together, so x to the 5th. Then we have y times y to the 3rd, so 1 and 3 make 4. So this could be simplified as 24 x to the 5th, y to the 4th. All right, for this last one, I'm going to have you guys try it, and then you'll check with me when you're done. All right, so we can visualize this. -2 times 8 is -16. A times a to the 2nd, 1a, and then 2 more a's would be a to the 3rd. Then finally, we have b to the 3rd. It is not being multiplied by any common bases, so we just rewrite b to the 3rd. All right, off to page 2. All right, so this is still a different way of simplifying exponents. So we're going to expand this out to just kind of understand this and then see if we can simplify it. So this c, we have 2 to the 2nd, and that's being raised to the 3rd power. So I'm going to first write what we're talking about. We're talking about 2 to the 2nd. So 2 to the 2nd means 2 times 2. Okay? And this base right here, 2 to the 2nd, is being multiplied by itself 3 times. So I'm going to write 2 to this times 2 again, or I could write 2 to the 2nd. That's the 2nd time, but I have a 3 right here, so I need to multiply by itself one more time. Okay. Again, this is just multiplying. My parentheses just mean multiplying, so I'm multiplying a base of 2 a total of 6 times. All right. For this next problem, we have 4x to the 2nd, and this base is being raised to the power of 2. So I'm going to write 4x to the 2nd, and I'm going to actually expand x to the 2nd. So 4x to the 2nd is just 4 times x times x. And this base is being multiplied by itself another time, 2 total times. So I'm going to go ahead and write that again. Now, when we simplify, we can multiply regular base numbers together. So 4 times 4 is 16. And then we see x being multiplied together a total of 4 times, so x to the 4th. All right, I want you guys to take a second and write any patterns that you might notice. All right, hopefully we notice something like when we have a power to a power, so this example right here, like C, we have 2 to the power of 2, and that's being raised to the power of 3. If we look at this problem compared to its answer, it looks like we can just multiply these exponents together. So we keep the base the same, and we could just multiply these exponents together, x times y, to come up with our simplified version. Okay. Now for the second problem, we have a product in the parentheses, so we have things being multiplied and then raised to a power. Okay, we have to do 4 to the power of 2, which is 16, and then we had to do x to the second to the power of 2, so that's x to the 4th. So a simplified version is if we have something multiplied together, raised to a power, that just means we have to raise every single thing to that power. All right, so we're going to do a couple examples. Apply properties of exponents to simplify each expression below. Remember to group like bases and then to apply any properties as necessary. Okay, so we have x to the 7th, and that's happening 3 times. So one way to simplify is to multiply 3 times 7 and get x to the 21st. All right, this one we have 7d to 7cd, and that's being multiplied by itself 3 times. So I'm going to multiply its little exponent, okay, 7 to the 3rd, because if I wrote that out 3 times, I would have 7 3's being multiplied together, okay? Then I would have to do c to the 3rd, because again, if I wrote it out 3 times, I would have a total of 3 c's. And then I would have d to the 3rd, because I would have 3 d's being multiplied together. Now we could simplify 7 to the 3rd because that isn't that big of a number. Again, you can use your calculator. 7 times 7 is 49. 49 times 7 is 343. So fully simplified, this value, this base, we will change it if it is a simple, pretty simple number. So 343, c to the 3rd, d to the 3rd. Okay. Now this problem, we have a big problem in the parentheses, and it's all being squared. So it's being multiplied by itself twice. So I'm going to do negative 12, and I'm going to square that. Okay. Then I have a to the 6th, and that's being squared. So that would be a to the 12th. I would have b to the 5th squared. I would have that twice for a total of b to the 10th. And then I have c, and if we square that, that would just be c squared. Okay. Then I look and see if I can simplify my base number pretty simply. Squaring is not that bad, so I'm going to do negative 12 times negative 12, and which would be 144. Okay. So again, I'm going to simplify my base numbers if they're fairly simple. A to the 12th, b to the 10th, c to the 2nd. All right, this problem is probably the hardest it can get to because it has a lot going on. So we're just going to break it up into pieces. So first, we'll just simplify this part, then we'll simplify this part, and then multiply them together. Okay, so we have 4x to the 2nd y, and that is being squared. So we have 4 being squared. We have x to the 2nd being squared. So that's a square would be a 4. And then we would have a y squared written out twice, which would be y to the 2nd. Okay. Then we have times. Now this 2 is not part of the parentheses or anything, so I'm just going to rewrite that 2. And then we have y to the 3rd, and that's being raised to the power of 4. So that means it would be multiplied by itself 4 total times. Y to the 3rd, y to the 3rd, y to the 3rd, y to the 3rd. So that would be a total of 12 y's being multiplied together right there. Okay. So now I'm going to group my numbers together. So I have 4 to the 2nd, which is 4 times 4. And I also have this times 2. Again, I can multiply any base numbers together. Okay. I also have x to the 4th, and that's being multiplied by no other x's. So I'm just kind of group that by itself. Finally, we have y to the second, and that's being multiplied by y to the 12th. So fully simplified, 4 times 4 is 16. 16 times 2 is 32. So my base numbers, my regular numbers, are simplified to just 32. We have x to the 4th, and then we have y to the second, so 2 y's, multiplied by y to the 12th, so a total of 12. And that would be a grand total of 14, so y to the 14. Okay. Melissa believes that the following expressions are equal for the value of b. Is she correct? Why or why not? Okay, so I want you guys to try this out and see if you can come up with is she correct or not. Okay, so I'm actually going to expand this out just to visualize this. We have b to the 4th times b to the 7th. There's 7. Okay. And then I'm going to do b to the 4th 7 times. 1, 2, 3, 4, 5, 6, 7. Okay. So looking already, I don't think that they're going to be equivalent, because if I look, there is a total of 11 b's being multiplied right here. Okay. And then there's a total of 28 b's being multiplied right there. Okay. You could also just apply the rules. If you know that we're multiplying bases, we could add the exponents together. And then if we have a power to a power, we can multiply them. You can tell that b to the 11th is not equivalent to b to the 28th. Okay. This next problem, the expression x to the 15th times x to the 6 raised to the 4th power is equivalent to x to the n power. What is the value of n? So it just wants to know what would this number be that it would be equivalent to this math problem. So when I look at this, I see it's just a 1 power. It's being multiplied by something that I could simplify. So I'm going to simplify this first. We have x to the 6th 4 times. So I'm going to multiply 6 times 4. 6 times 4 is 24. Okay. So now I have x to the 15, so it means I have 15 x's in a row being multiplied by 24 more x's in a row. So that shortcut is just to add the grand total together. So that would be x to the 39th. Okay. So it says, what would the value of n be? Well, n would have to equal 39 for them to be equivalent. All right. Sandra simplified 3x to the 3rd, or all raised to the 3rd, times 3x to the 2nd, all raised to the 4th power. She made a mistake somewhere, so we're going to try and figure out where her mistake was. Okay. So the way I kind of do these is I just do them the way I would do it and then just kind of go with that. So I have 3x raised to the 3rd power. So I could write 3x 3 times, or just know 3 is being multiplied by itself 3 times, and x is also being multiplied by itself 3 times. So when I look at her work, it looks like she's good so far. Okay. Then we have 3x to the 2nd raised to the 4th power. So I'm going to do 3. If I would multiply that out 4 times, 3 would be multiplied together 4 times. And then we have x to the 2nd written out 4 times. And we can multiply, that would be a total of 8 times. Okay, so I'm checking, and she also has that. So it looks like her work for the first row is correct. All right, now it looks like she possibly grouped them together with common bases. So it looks like she put 3 to the 3rd times 3 to the 4th together. And then she put her x to the 3rd times her x to the 8th together as well. So again, I agree. I think that's something that she could do. You might not have to actually write it out, but she did. You could just visualize it as well. Okay. So then if we have 3 to the 3rd, that'd be 333 times 3 to the 4th, 3333. Okay. I see a total of 7 3's being multiplied together. Okay. Then if I look at my x's, I have xxx and then xxx 8 times. So that would be a total of 11 x's. So for me, I see 3 to the 7th times x to the 11th as the simplified version. Okay? So she wrote 3 to the 12th and x to the 24th. So if I look at my work, it kind of looks like she multiplied the exponents instead of adding. Okay. And the final one is the area of a circle can be written using the formula area equals pi r squared. Write an expression to represent the area of a circle that has a radius of 5x to the 7th, y to the 3rd. Leave your expression in terms of pi, which just means we're just going to keep this variable pi as a variable the entire time. We're not going to use it as 3.14. Okay, so area equals pi r squared. So it's telling us that the r, the radius, is 5x to the 7, y to the 3rd. Okay, so I know I had to multiply them, and since this is such a big thing, I used parentheses. Okay, now I need to square that. Okay, so that just means to multiply by itself twice. So we have 5 being multiplied by itself twice. 5 times 5 is 25. Okay, then we have x to the 7th twice, so that would be x to the 14th. Then we have y to the 3rd twice, which would be y to the 6th. So this is the radius squared. Then we just have the pi symbol. So you could put it out in front, you could put it out behind, but the area would just be written as pi 25x to the 14th, y to the 6th. All right, I hope you guys feel semi-comfortable with this. Today you're going to practice these 11 problems, and then we'll check it tomorrow and kind of see where we're at and then practice a little bit more. See you then.